If the addition of oxygen takes place, it also called as oxidation. Reduction process which any one of the following chemical changes takes place. Reaction in which electrons are transferred from one atom to another are called oxidation reduction reaction. Any oxidizing agent itself get reduced, we call it as oxidizing agent. Hello students, I am Ramya, lecturer in chemistry from Vidhyaashram, the Temple of Excellence, Mysuru. In this particular session, we are going to discuss about oxidation, reduction, redox reaction in terms of electron transfer reaction, reducing agent and oxidizing agent, oxidation number or oxidation state. Oxidation. During the oxidation, removal of electron takes place in different ways. So, oxidation is a process of one of the following changes takes place. So, if the addition of oxygen takes place, it also called as oxidation. Burning of magnesium, that is Mg plus O2 gives magnesium oxide. This is the oxidation process. And removal of hydrogen. In dihydrogen sulfide reacts with chlorine, it forms hydrochloric acid. The removal of hydrogen, we call it as oxidation. And addition of electronegative atom. So, if we consider any electronegative atom like fluoride, chloride, iodide or bromide, magnesium reacts with chlorine, gives magnesium chloride. This is the oxidation of magnesium. Then removal of electropositive element. In this example, removal of electropositive potassium. This is the potassium comes under S block element. We call it as more electropositive in nature. Here there is a removal of electropositive element like potassium is also comes under oxidation process. So, oxidation is defined as addition of oxygen or electronegative element or the removal of hydrogen or electropositive element from a substance. We call it as oxidation process. Reduction. Reduction is a just reverse of oxidation. Reduction process which any one of the following chemical changes takes place. For example, number 1, removal of oxygen. Removal of oxygen in the mercuric oxide, removal of oxygen takes place. That means a reduction of mercuric oxide, call it as reduction process. Removal of electronegative element, that is here chlorine is a electronegative element. There is a reduction of ferric chloride considered as reduction process. Here the removal of chloride takes place. Addition of hydrogen to the ethene molecule, hydrogen gas is passed over ethene, gives ethane, that is reduction of ethene. Addition of metal, addition of any metal to the mercury chloride or for example mercury chloride reacts with tin chloride, it also form a reduction of mercury chloride. So, the reduction can be defined as the removal of oxygen or the electronegative element from a substance or addition of hydrogen or electropositive element from a substance. We call it as reduction process. Redox reaction in terms of electron transfer reaction. Reaction in which electrons are transferred from one atom to another are called oxidation reduction reaction. So, the loss of electron is called oxidation and gain of electron is called reduction. For example, in sodium there is a loss of electron takes place, loss of 2 electron, we call it as sodium get oxidized. In the chlorine there is a gain of 2 electron takes place, the chlorine gets reduced. Here sodium is oxidized and chlorine is reduced. Sodium oxidized whereas oxygen is reduced, and loss of electron from sodium, we call it as oxidation, and gain of electron to the sulfur, we call it as reduction. Reducing and oxidizing agent or reductant, a substance that can readily lose electron to other substance is called reducing agent or reductant. Oxidizing agent or oxidant, a substance that readily accept the electron from the other substance, we call it as oxidizing agent or oxidant. So, reducing agent are electron donors and oxidizing agents are electron acceptor. The substance are the element which accept the electron, we call it as oxidizing agents, that are electron acceptors. Reducing agent which donates the electron, we call it as electron donor. Example 1. Here, reducing agent, the hydrogen itself get reduced and it gains of 4 electron. The oxidation is loss of 4 electron. This is reducing agent because itself get oxidized. Any reducing agent get itself oxidized, we call it as reducing agent. Any oxidizing agent itself get reduced, we call it as oxidizing agent. Oxidation number or oxidation states. Oxidation state or oxidation number of an element in a compound is real appropriate change on one atom of the element. Example, oxidation number of sodium in sodium chloride is +1. Since the real charge on the atom of sodium in sodium chloride is +1. Similarly, the real charge of the atom chlorine is -1. Hence, the oxidation number is -1. Oxidation number of hydrogen and oxygen in water are +1 and -2 respectively, since the appropriate charge on the atom of hydrogen and oxygen are +1 and -2 respectively. Rules for assigning oxidation number. Oxidation number of an atom in the elemental state, that is 0, that means uncombined state, that is 0. For example, evidently oxidation number of each atom in chlorine, hydrogen, nitrogen, oxygen all are 0. The oxidation number of an ion is equal to its charge. For example, sodium oxidation state is +1, like that. Chlorine for chloride is -1. For Mg, magnesium for 2+. For magnesium ion, it is 2+. The oxidation number of hydrogen in all compound contain hydrogen is +1, except when hydrogen form compounds with hydrides. Hydrides means when hydrogen combines with alkaline or alkaline earth metal, it acquires negative charge. Except that case, in all the case, oxidation number of hydrogen is +1. The oxidation number of oxygen in all the compound containing, that is -2, except in peroxide it has -1 and superoxide in which -1/2. For example, in water oxidation state of oxygen -2, in hydrogen peroxide oxidation state of oxygen is -1, in superoxides like oxyfluorides and dioxygen fluoride, here +2 and +1 respectively. The algebraic sum of the oxidation number of all the atoms present in a one molecule in a compound is 0. Calculation of oxidation number of underlined atom in the given compound. For example, sulfuric acid, here the oxidation number of sulfur we can calculate it by using simple mathematical equation, that is 2 hydrogen is present, that is 2 into plus 1, that is the oxidation number of hydrogen, plus X. Sulfur can be considered as X because unknown oxidation number, plus we have a 4 oxygen, oxidation number of oxygen is -2, that is equals to 0. We get the X value plus 6. So, the oxidation number of sulfur in the sulfuric acid is plus 6. Like that, in the case of potassium dichromate, let the X be the oxidation number of chromium ion or atom. 2 plus 2 into plus 1 plus 2x, because we have a 2 chromium here, it has to be multiplied with 2, and 7 oxygen with the oxidation state -2. We get the X value plus 6. So, the oxidation number of chromium in potassium dichromate is plus 6. In the next session, we are going to discuss with the stock notation. Thank you.